The next section in Chapter 10 talks about area and perimeter again, but this time it's going to be on a coordinate plane. So, by the end of this lesson, you should be able to find perimeters and areas of figures if they are in the coordinate plane. So, because we have stuff with coordinates, we can think about the distance formula and the slope formula, and we're going to use those a lot today. So remember, the distance formula is basically just a squared plus b squared equals c squared, but we took the square root here, and then you plug in the distance. But because we have a grid to plot, we can count, and those are going to be our a's and our b's. And then remember slope, y2 minus y1 over x2 minus x1, and it's rise over run. So this first one, draw and classify the polygon with these vertices, find the perimeter and the area of it. So we're going to plot -1, -1, 2, -2, -1, -4, and -4, -3. So here's our polygon. And to me, this looks like a parallelogram. But before we can say that, we have to prove that it's parallelogram. So I'm thinking parallelogram. And remember, there's a couple conditions that make something a parallelogram. Its opposite side lengths are the same, opposite angles are the same, consecutive angles have to be supplementary, on and on. The easiest one to prove on a coordinate plane is that the opposite sides are parallel. So let's find the slope of the opposite sides. If I'm looking at HE, it goes up 1, 2 over 1, 2, 3. So slope of HE is 2/3. Now the opposite one, GF, should be the same, up 1, 2 over 1, 2, 3. So we know these two are parallel. And then do the same thing for HG and EF. So HG, I'd go down 1 over 1, 2, 3. And -1/3. And EF, I'd go down 1 over 1, 2, 3. So because I know that these are parallel to each other, I can say for certain that this is a parallelogram. So now to find the perimeter, I need to know the distance all the way around. But because it's a parallelogram, I know opposite sides have to be congruent. So I only need to find the distance of two sides. So let's find the distance of HG. HG and EF are going to be equal. So I can use Pythagorean theorem to figure out that length. So I'm going to take the square root of 1 squared plus 3 squared. So that's 1 plus 9. Add them up, we get the square root of 10. Since we're going to end up finding perimeter, we want to actually get a number value for this. So if we type this in our calculator, you get about 3.1. And then we're going to do the same thing. GF and HE have to be the same length. So we'll do Pythagorean theorem again. We have up 2 this time and over 3. So this is 4 plus 9, or square root of 13. If you type that in your calculator, it's about 3.6. So my perimeter has to be 2 of each of those, and add them up. So 3.6 plus 3.6 plus 3.1 plus 3.1. We end up with 13.4 is our perimeter. Alright, now to find the area. And I'm going to show you two different ways to find the area. The first one is to break this up into shapes that we know how to find the area of. So if I slice this right here, I end up with two different triangles right here. This length I can quickly count as 3. And if this is the height of one of my triangles, that's also 1, 2, 3. So this triangle right here is 1/2 base times height. So 1/2 of 3 times 3. 3 times 3 is 9. Cut it in half, you get 4.5. And then we can do exactly the same thing with this triangle over here. It has the same base, has the same height, so you end up multiplying that by 2, and you end up with 9 units squared, and that's the area of that parallelogram. The other way to find area, and this works best when you have a weird shape like this one that they give you, is to draw it and then subtract areas out. So find the area of this polygon with the vertices -2, 4, k is up here, L is 6, -2, M is 4, -4, and N is -6, -2. So because I could sit here and break this up into triangles and then find the area of all of those, or we can make a shape that connects all of these vertices. And if we make a shape that connects all of the vertices, we end up making 4 triangles that we can subtract out. So the area of this whole rectangle is base times height. So my height is 1, 2, 3, 4, 5, 6, 7, 8. And the base is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if you multiply 8 times 12, you end up with the area of this entire thing right here, which isn't what we want, but it's a step closer. So now we can subtract out all of these triangles here. So this first triangle, 1/2 base times height. The base is 1, 2, 3, 4. The height is 1, 2, 3, 4, 5, 6. So you cut 24 in half. We're going to take out 12 units squared. And then do this again. Let's try this triangle down here. Formula is the same. This time my base is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And my height is only 2. So we'll take out 20 units squared. Let's do this little triangle here. Same formula. This time my base is 2 and so is my height. So we're going to take out 4 units squared. Last one, the biggest triangle here. My base is 1, 2, 3, 4, 5, 6, 7, 8. And it is 1, 2, 3, 4, 5, 6 tall. So 4 times 6 gives you 24 units squared that we got to take out. So if we have 96 of the whole thing, take out the blue triangle, take out the red triangle, take out the orange one, and then take out the purple one, we end up with 46 units squared. And that has to be the area of the shape that we need. I like this way a little better than cutting it up, but sometimes cutting it up is the better way, like in this parallelograms case here. Had we made the thing all the way around, we would have had to find areas of 4 triangles. For this one, we just had to find the area of 2. So it depends on your shape, depends on how much cutting up you want to do. So you should be able to find perimeters and areas of figures when they're in the coordinate plane. Write down any questions you have and we can go over them in class. Enjoy your night.